One of the last things that we're going to talk about when we're talking about sound is something that's known as beats. And beats is very simply the variation in loudness of a sound due to the constructive and destructive interference of slightly different frequencies. And what do I mean by that? I'll show you a cool demonstration in a second, and you can actually do that demonstration yourself, which will probably drive the sub insane. That is, of course, if any sub even showed up. Wink, wink. Seriously, though, if no sub is there, somebody please go to the office and please find one. Thank you very much. But I do appreciate how well behaved you were. But moving forward with beats, well, take a look here. If I have two waves that have the same frequency, but they're lined up in just such a way that their amplitudes line up. Well, if I'm adding these two waves together, if this one is occurring at the same time that this one is occurring, hopefully you're starting to see that what I'm going to get is a combined wave that has constructive interference occurring. Okay, so what you wind up is one larger wave. If we take a look over here, well, I have the same frequencies on these waves, but they're offset just enough that the crest of one lines up with the trough of another, the trough of one lines up with the crest of another. So what you get here, hopefully you realize this is destructive interference, and what I wind up with is no wave at all in this case because it entirely cancels out. So entirely adds together, entirely cancels out. If I had something in between the two, well, you'd have some constructive and some destructive. It would kind of fluctuate a little bit. Now, where beats comes into play is it gets kind of interesting. It's when you have something that's slightly different. Two frequencies are slightly different. So this is going to continue to loop through. But the important thing to realize is that if you take a look, like right here, we have perfectly destructive interference. The trough of this wave meets the crest of the other. But since they're slightly different frequencies, if you look at each next following wave, they start to go out of sync. And then they start to come back in sync until the point where they're, again, destructively interfering. So they're going to continue over, and there's actually going to be a point, if you look right here, there's a point where you have constructive interference, maximum constructive interference, and you get a very, very large amplitude. But then it starts to offset again, so your amplitude shrinks, down to the point about here where you have complete destructive interference. Then as they're offset, you begin to get closer and closer and closer in line until you have your maximum constructive interference, and so on and so forth. So this is wave one, this is wave two, and this is the product of these two. They're going to start to constructively interfere, and then destructively interfere, and then constructively interfere, and then destructively interfere. And that's going to happen due to the fact that these frequencies are so close together. They're not perfectly aligned. If they were perfectly aligned, you'd either have only constructive or only destructive. But in this case, you actually wind up with a slight change in frequency. Now, every time this amplitude increases, you get an increase in volume. So you hear like a wow, 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 wow. So you hear what we call beats. This is what we refer to as beats. It's increases and decreases in loudness. That is very simply just the result of two frequencies that are very close but are slightly off. Now to show you a demonstration of this, it's actually kind of cool. You can do it on YouTube yourself. So all you have to do is go to YouTube, and you're going to go ahead and you're just going to search for different frequencies. So here I have a 438 hertz frequency, and this is what a 438 hertz frequency sounds like. So hopefully you realize that is just a solid noise. There's no fluctuation whatsoever. It's just a solid noise all on its own. Now this is YouTube, so I can't change this. But what I can do is I can go find a 440 hertz. And again, a 440 hertz noise, nothing fluctuating about it. It's always 440 hertz. Now, it is different than the 438. There's a 2 hertz difference. So what we have here is these two waves, essentially, in the case I'm talking about, are off by 2 hertz. Now, the math is actually fairly simple for this. The number of beats per second you will hear will be the difference in frequency. So if I have a 438 and I have a 440, well, if I play them individually, I get two, fairly close, but two different frequencies. What becomes interesting is what happens if I play this one, and while this one is playing, I go back and I play the 440. Well, there's a 2 hertz difference, so I can expect to hear 2 beats per second, because 438 to 440 is 2 hertz, so 2 hertz equals 2 beats per second. So if I play this, and then I go and play the 440 hertz at the same time, Nope, I apologize. This one likes to turn itself off. And as soon as I pause one, I still just get the other frequency. This is no kind of computer trick. This is literally what happens when you just play two frequencies that are fairly close. So now if I go from a 438, and I apologize, for some reason this one likes to shut itself off sometimes, but if I go to 438 hertz and I play a 442 hertz, well, take about 5 seconds, predict the number of beats per second that you're going to hear. So again, 438, 442. Again, this is a solid tone, which also likes to shut itself off for some reason. And this is, how's my singing voice? Terrible. 442 hertz versus 438, that's 4 hertz. There's a difference of 4 hertz. So if I were to play both, I should hear 4 beats per second. So let's test this out. And that's exactly what I get. And this one keeps shutting itself off. Man, YouTube really wants to make me angry today. Well, it's working, YouTube. You win. All right, so now let's go ahead and we'll take it one step further. What if I go from a, let's say 442, and at the same time I play a 450 hertz? Well, what's the difference in frequency? 442 to 450 should be 8 hertz, so I can expect to hear 8 beats per second. So if I play a 450 hertz, along with a 442, hard to catch, but that is 8 beats per second. Now, if I leave my 450 on and I were to play a 440 at the same time, hopefully you figure out at this point, 440, 450, 10 hertz, what am I going to wind up with? I should wind up with 10 beats per second. Now, that's getting to the point where it's going to be, you probably can't even detect 10 per second, but you should be able to notice that it is much higher than before. If you were to be able to count it, 10 beats per second. So here's my 440. Here is my 450. Very clearly again, they are single frequencies. But as soon as you play them both together, in this case, 10 beats per second. Kind of cool thing. You can do it on YouTube. You can do it if you just have any kind of frequency generator. But kind of a cool trick to show people, because you very obviously have one frequency, you have another, and then as soon as you play them at the same time, due to that constructive and destructive interference, that alternating interference, you wind up with a beat pattern, which is or beat frequency, which is actually kind of cool. Kind of cool little YouTube experiment or demonstration you can show people. Just blow their minds. Just make sure you can explain the constructive and the destructive interference, because it's a little bit less impressive when you go, how cool is this? And they say, that is awesome. How does that happen? And you go, I don't know. YouTube and science and things. Doesn't sound too intelligent. We like to sound intelligent. Constructive, destructive interference, kind of alternating, slightly different frequencies. Now you can also show a really cool trick, sound really smart, and hopefully get the question right on the test when I say you have this frequency and this frequency. How many beats per second can you expect to hear?